This robot walked down the runway so realistically that people accused the company of building a fake robot. The incident went viral worldwide. Some people even claimed there was a human inside it. The controversy grew so large on social media that the company's stock was affected, until the CEO walked onto the stage and personally cut the robot open in front of everyone. But was the situation really what people thought? Was the robot fake? The way it stood, walked, and moved exactly like a human had completely turned public opinion against them, but they proved it. So how did they do it? Let's take a closer look at XPeng's Iron robot. XPeng originally started with robot dogs, but after spending millions of dollars, the company realized something important. The world wasn't designed for four-legged machines. It was designed for two-legged humanoids. That realization pushed them toward humanoid robots almost overnight, and they abandoned the previous project entirely. By studying the human skeleton and body ergonomics, they managed to build a robot with a flexible spine that could even mimic the movement of a real human body. The Iron robot, with its catwalk-style walk and flexible spine, was expected to impress people during its first public appearance. Instead, it was accused of being fake. The CEO knew there was only one way out of the situation. Everything had started on the runway, and it would end there too. Just one day after the controversy exploded, he walked onto the stage in front of everyone and cut open the robot's leg with scissors to prove it was real. And yes, it was all real. They had actually built a robot that walked like a human. After that moment, the company's stock price surged. When XPeng Iron's leg was cut open, what we really saw wasn't just proof that it was a robot. We saw how far engineering and technology had advanced. The robot is covered with a special artificial skin. This material is fabric textured, flexible, and most importantly, breathable. Thanks to this skin, the robot can transfer internal motor heat outward without making people uncomfortable, while also creating the feeling of a living being. Another major feature of Iron is its use of solid-state battery technology, something never before used in a humanoid robot at this level. Because of that, it can safely operate around humans without the same explosion risks associated with traditional battery systems. Another technological breakthrough is its head. Even without visible eyes, Iron uses an eagle eye sensor system that gives it a full 720-degree field of awareness across vertical and horizontal tracking, essentially eliminating blind spots entirely. The robot itself is built almost like a perfectly fit human, 5 feet 10 inches tall and around 154 pounds. But now we get to the feature that truly separates it from the competition: degrees of freedom. Iron has a total of 82 degrees of freedom across its entire body, including the neck, shoulders, elbows, hips, and ankles. For comparison, Atlas has 56, followed closely by Tesla Optimus. Iron operates at nearly 1.5 times that level, and that alone explains what it took to achieve that runway walk. Its hands alone contain 22 degrees of freedom. The fingertips are equipped with microscopic touch and pressure sensors, allowing it to grip soft materials like fabric without tearing them. XPeng even claims it can assemble automotive parts with near-zero margin for error. So where exactly will this robot fit into the industry? Heavy manufacturing or the service sector? XPeng originally developed Iron for automotive factory assembly work, just like many other humanoid robots. But the tests failed. The robot's hands wore down within a month, making it too expensive compared to human labor. Even though the company didn't completely abandon the idea, they realized a delicate robot might be better suited for a more delicate and people-focused industry, the service sector. In fact, Iron is expected to appear soon inside XPeng showrooms as an assistant that greets customers, introduces new vehicle models, and even helps with sales consultations. XPeng also became one of the first companies to openly gender its robots as male or female, while allowing customers to customize them almost like buying a car. That means it may eventually be possible to purchase versions with long hair, wider hips, more defined body features, and even runway-style movement patterns, or choose a fully masculine design instead. So even if the company couldn't fully turn Iron into a factory worker, it may still succeed in transforming it into a personal service product capable of blending into everyday life. Let's now look at the financial side. What does iron actually cost? The early stage price is around $150,000. At this level, the target market is strictly enterprise and industrial customers. XPeng management has also publicly outlined a long-term investment plan of around 100 billion yuan, roughly $13.8 billion, dedicated to this robotics push. XPeng already has a major advantage: a proven large-scale manufacturing system from its electric vehicle business. By leveraging its existing automotive production lines and supply chain infrastructure, the company aims to rapidly reduce costs and move toward mass production, potentially starting as early as 2026. The real story, however, is competition. By the time Tesla's Optimus reaches full-scale production, Iron may already have secured a strong position in the Chinese market. But achieving that will require much more than just a walk on a runway. If we ask how this robot will affect our lives, the answer is simple. Right now, it doesn't. We are still at the very beginning. But what sets it apart are several key features. Its ability to learn is different from others. It essentially imitates humans, makes decisions on its own, and operates with programming designed only to enable thinking, not rigid execution. Another important advantage is the transfer of automotive technology into robotics. While Tesla has attempted this, it has not yet fully succeeded. XPeng, on the other hand, became a company that integrates its VLA model with massive driving data sets, including over 65,000 years of accumulated driving data, combining autonomous driving systems and robotics on a single platform. Looking ahead, it seems likely that it will be highly successful in the service sector, which could eventually put pressure on jobs in that field. For now, the imbalance between cost and performance slows this transition, but in the long term, anything is possible. And if robots are already learning and improving themselves, then no matter what we do, we also need to keep improving ourselves. Thank you for watching until the end. Don't forget to subscribe, and I'd be curious to hear your thoughts about the future in the comments.